Hi everyone, welcome back. So this is pre-calc 11. We are doing 5.3 coterminal angles. As you can see, I already have the get started part on the screen. I did not take a picture of the book this time. I think I can manage with this. And the first thing for us to do is to sketch 210 degrees in standard position and find the reference angle. So the reference angle is an angle or no, an angle in standard position would be an angle whose initial arm is on the positive x and it goes in a counterclockwise direction. All right, so let's see how this works. So begin with x and it goes that way, and that's 180 degrees, 210, so probably a little bit something like this. Okay. So of course it is just an estimate, so maybe something like this. Okay. So there is your theta. Theta is equal to 210 degrees. Okay? So there is your angle of standard position. Now, what is its reference angle? So the reference angle is defined as that acute angle whose terminal arm, or rather, an acute angle, and the measurement is seen by figuring out how far the terminal arm is from the x-axis. Doesn't have to be the positive x, could be the negative x, as long as it's going to be from the x-axis. Okay, so let's see. So the terminal arm of 210 degrees is this one, right? So we ask ourselves, how far is it from the x-axis? Okay, so it's this one here. So that would be 210 minus 180. So that would be 210 minus 180 degrees. I need that space here, so let me put it here. 210 minus 180 degrees, and that would be equal to 30 degrees. All right. So really, this reference angle, which I would write as theta sub r, that's reference, would be equal to 30 degrees. Okay. Okay. So what would be the exact value of each trig ratio? Now remember, we are trying to figure out the exact value of the trig ratio for sine of 210, cosine of 210, and tangent of 210. Now, we understand that since the reference angle is 30 degrees, perhaps we can just figure out the trig ratios of 30 degrees, which means find the sine of 30 degrees, cosine of 30 degrees, and tangent of 30 degrees. And those values we will have to think about how they are affected when they are in quadrant 3. Okay, so let's continue. So the sine of 210 degrees, all right, the sine of 210 would really be the same as the sine of 30 degrees, okay? But then it has to be in quadrant 3, all right? So what we can do is figure out, okay, what if we get the sine of 30 degrees? But our angle is in quadrant 3, all right? But theta is in quadrant 3. So how is it affected? Well, in quadrant 3, according to CAST, the sign is what? The sign in quadrant 3 is negative, okay? Therefore, as long as we can get the sine of 30 degrees, whatever that value is going to be, we will just make it negative, all right? Now, sine of 30 degrees, if you will remember, would be equal to 1/2, okay? But since it is in quadrant 3, therefore, sine of 210 degrees would be negative 1/2. Okay, cosine of 210. Let's think about that in terms of the cosine of 30 degrees. but again in quadrant 3. All right. Therefore, the cosine of 30 degrees is equal to the root of 3 over 2. All right. Now, if you use a calculator, you will see it will give you a decimal. Avoid doing that. All right. Avoid using your calculator, especially if you are being asked for an exact value. But since it is in quadrant 3, therefore the cosine of 210 degrees. Cosine in quadrant 3 is negative, so that would be negative of root 3 over 2. Okay. Now, the last one is for us to get the tangent of 210. Now, the tangent of 210 is it's really the same as the tangent of 30 degrees, but in quadrant 3. But theta is in quadrant 3. All right. What does it mean? Now, the tangent of 30 degrees is what? The tangent is opposite over adjacent or sine over cosine. That would be 1 over, uh, or what is our sine? 1/2 over root of 3 over 2. Okay. And you will see that the 2's can cancel out, leaving you with just 1 over root 3. Or if you rationalize the denominator, it would be root 3 over 3. Okay. So if your question might be, so do we rationalize the denominator? But in terms of pre-calc 11, I would want you to rationalize your denominator. But really, when you get to post-secondary, since they are not checking whether you understand how to rationalize the denominator, if you leave your answer as 1 over root 3, that would be good enough. Okay. But for our purpose, I just want to make sure that you still remember. Okay. So whenever possible, try to rationalize it. I understand that sometimes the book itself does not ask you to rationalize, so it's okay. All right, it's not too much of an issue. All right, so here we go. So when we sketched 210 degrees in standard position, we found its reference angle. 210 degrees is that angle which is drawn in red. The angle of standard position, or the measurement of the reference angle, is 30 degrees. All right, and I just showed you how to get the trig values, the exact values of each trig ratio for this uh, angle. Now, by the way, tangent is positive in quadrant 3. All right, so if you're thinking, wait a minute, how come you never talked about positive or negative in quadrant 3 for tangent? Well, tangent is positive, that's why. Okay. Okay, so now what are coterminal angles? I'm now going to page 440. I am skipping page 439. Okay. So hopefully you would have read through um, this first 2 pages to familiarize yourself with what it is. But if not, that's totally fine. All right. You can just go back and read page 439 after watching this video. So coterminal angles are angles that have the same terminal arm. All right. What does it mean? So let's say you have an angle. You have an angle like 45 degrees. All right. So 45 degrees would be something like this. There is your 45 degrees. Okay. Now, if you continue around the circle, or if you continue going around, okay. And what do I mean by that? If we go this way, and then continue on 180, 270, 360, and then stop there again. This time you have an angle that went the whole way. So that angle would have been 360 plus 45 would be, what is that, 405 degrees. All right. So what does that mean? 405 degrees would be a coterminal angle of 45 degrees. All right. Now, remember that you can just go around and around and around, and as you go around, you are just really adding 360 degrees every time. Okay. So what about another one? So if we do it again, we go this way. So we go around 360, we go again, that's 720, and then we stop here. All right. All right. So the next angle we're gonna have is, all right. We went around twice, so that's 720 degrees. Um, plus 45, that's 720 plus 45, 765, right? Okay. 765 degrees. Okay. So 765 is also a coterminal angle for 405 and for 45. All right, so I think you already got the idea now. Coterminal angle is an angle, okay, that would have the same terminal arm as the given angle. Now, when we went counterclockwise, these angles are measured in positive terms. Now, if you have read through the book, or you probably have heard of this somewhere, there are negative angles. Okay, negative angles is just going in a clockwise direction. Therefore, okay, so we know that the 45-degree angle would be like this. All right, so let's take a look. um, let me just do something here. All right. I'm going to create another XY plane. Okay. And then I'm going to have the 45-degree angle again going this way. Something like this. Okay, so that's 45 degrees. Now, if we go the other way, if we go clockwise, okay, going this way. So as we go this way, that's negative 90 degrees, negative 180, negative 270. And what would that be? Well, really, if we go the full turn, it would be 360. Therefore, we just subtract 45 from 360. So this one would be negative 315 degrees. Okay. Negative 315 degrees also is a coterminal angle for 45 degrees. Okay. So just like what we did earlier, we can find another negative coterminal angle by going further. So if we do another one, negative 360, negative 450, negative 530, negative 620, and then we end here. All right. Negative 315, that would be negative 675. All right. Negative 675 degrees. All right. Now, if you're thinking, what is the math that I'm doing? Well, all I did was I looked at negative 315 degrees and then I subtracted 360. All right, that's what I was doing. Okay. I wasn't really adding, 90, 180, 270 every time. That's too inefficient. All right. So there you go. That is the meaning of coterminal angles. These are angles that have the same terminal arm. And if you go in a clockwise direction, counterclockwise direction, the coterminal angles you have would probably be a positive an angle, or if you go on a clockwise direction, it is a negative angle. Okay, so let's talk about check your understanding number one. Okay, check your understanding number one. Determine the measures of all the angles in standard position from 0 to negative 1200 that are coterminal with an angle of 280 degrees in standard position, and then sketch the angles. Okay. All right. So coterminal to 280. That's what we have to do. Coterminal to 280. Oops. 280 degrees. All right. Okay. So, but it is from 0 to negative 1200. All right. 0 to negative 1200 degrees. Okay. Okay. So, if you want, you can actually um, draw the angle first. I mean, some of you might want to do it that way. All right. So yeah, sure. Let's draw the angle first. Okay. So coterminal to 280. So if we start here, 90 degree. Oops, sorry. No. Okay. 90 degrees, 180 degrees, 270 degrees. So maybe here. All right. That would be about 280 degrees. Okay. 280. That's our data. Now we are looking for a negative angle. Okay. What does that tell you? So that means we go the other way. All right. But the question is, what is that angle that would be going this way? That would be coterminal with this. All right. Theta equals what? Well, if you go this way and that's 280 and the whole turn would be 360, what would that be? Well, that would be 80 degrees, right? To complete the full turn. But then since you are going in a clockwise direction, instead of writing 80 degrees, it is negative 80 degrees. Know what I mean? Okay. What would be another coterminal angle? Because we are looking for coterminal angle between 0 to negative 1200. So we will be looking for angles that would be negative, and it should be less than until we get to negative 1200. So maybe there's just another angle, and in fact there is. If we are to go this way, or we are to go this way, negative 360, and then, oops, there you go. And what is that green angle? That would be negative 80, all right, minus 360, and that would be negative 440. Now, if you're thinking, why did I subtract 360? Well, it's like adding a negative number, all right? That's what I actually did, plus negative 360, all right, because I went clockwise. Okay, so can we find another one? Yeah, let's see. All right, let's try yellow. All right, so negative 360, negative 720, and then we end here. All right. So what is that? Negative 440 plus negative 360 or minus 360, and that would be oops. Okay, that would be negative 800, right? Okay. Now we're getting very close to negative 1200 degrees. So let's see, can we have another one? So let's try this one, this color here. So do it again, 360, 720, 1080, and there you go. All right, this next data is negative 800 minus 360 is equal to negative 1160. All right. So negative 1160. Now, should we go another turn? No, I don't think we need to do that, because if we do that, we will just go beyond negative 1200. All right. So the reason why I showed you the movement of the angles as I went around in a circle is that it asks us to sketch the angles anyway. So I just did it right away instead of getting the angle first and then sketching it. It's pretty much the same thing. Okay. Now write an expression for the measures of all angles that are coterminal with an angle of 280 degrees in standard position. So it wants us to create an expression wherein we will be able to figure out the measurement of all angles that would be coterminal. So it's like if you continue on and on and on for an infinite amount of turns, you will always be able to get the coterminal angle. What does that mean? So what you do is this. So if you notice that we actually started with 280 degrees, all right? Now, if you think about it, 280 degrees, all right? A coterminal angle to 280 degrees would be to add 360 to it, isn't it, as you go around? Now, 280 plus 360, what would that be? 280 plus 360 would be 640. All right, 640. So that's one coterminal angle that I found. And then if I add another 360 to 640 as I go another full turn, that would be 1000, which is like 280 plus 360 plus 360, which is actually 720, right? Which is 2 times 360 is equal to 1000, right? Now, 280 plus, if you go another turn, 3 times 360, that would be what? Okay, 1000, you just add 360 to it. That would be 1360. Okay. Now, do you notice that what I'm doing is just adding 360 every time, or multiples of 360? So really, if you think about adding negative 360 instead, which is what happened when we got the negative coterminal angles, like for this one here, that is just the result of through 280 minus 360, right? Or plus negative 360, and it gives you negative 80 degrees. And then you added negative 360 after, giving you negative 440, and so on and so forth. So really, to be able to get this, the expression that would give you all of the coterminal angles would be 280 degrees plus 360 times n. All right. Now I know that in the answer key it says 360k. They're just using a different letter. All right. It's one and the same. I don't really put the variable in front of the number. The number should come, usually comes after the variable. Now some of you might be wondering what this means. N is an element of the integer, set of integers. What does it mean? Because as you use a value for n to be able to create multiples of 360, n has to be an integer, meaning it can be -1, it can be -3, it cannot be 1.5, it cannot be square root of 7. Why? Because if that is so, it will throw off the coterminal angles. Okay, it will not give you the right numbers. So check your understanding number 2. Oh, but before that, I would like to talk about principal angles. All right, so what is a principal angle? Okay, so I wasn't able to write it here right away, so I'll just write it down. What is a principal angle? Okay, a principal angle is the least positive angle that is coterminal with an angle. Least positive angle that is coterminal with a given angle. With a given angle. Now this definition I just actually copied straight off of page 441 at the top part. Definition on page 441. All right, so look at your workbook just before example 2. All right, so this one is pretty easy. Okay, so determine the principal angle for 1203 degrees. So the principal angle would be the least positive angle. All right, that is coterminal with a given angle. So really, if you think about it, that principal angle would have to be what? It should be less than 360. Now, if you're thinking, what? Well, if it is more than 360, it means that you just went around a full turn and then you just ended again with that same terminal arm. Okay? So the principal angle for 1203 degrees would be like this. So let's see. All right, so let's draw it again. Let's see where this guy is. Okay, so we have what 1203 degrees. 1203. Okay, so we go around 180, okay, 360, go around again, full turn 720, we go around again 1080. Oops, so 3 full turns is 1080 degrees. Yeah, okay. Now you have to understand that if you go another full turn, you add another 360, it is going to go beyond 1203. All right. So that means you just have to go some more to be able to get 1203. So 1080, if we are to continue with this, okay, so I'll use a different color now. If I'm going to continue for another 90 degrees, 1080 plus 91, 170. So I still need some more, probably here. All right. There is the terminal arm. Okay, so really, the least positive angle that is coterminal with this is this angle right here. And that would be what? Well, that could be computed by subtracting 1080, which gives you 123 degrees. And there you go. All right. I think that's pretty obvious. That's pretty easy. All right. Now, find the for letter B, find the principal angle to write an expression for the measure of all the angles that are coterminal with 865 degrees in standard position. Okay. Okay. Let's see. So to find the principal angle for all angles, principal angles, to write an expression for the measures of all the angles that are coterminal with 865 degrees in standard position. All right, so this is what we're going to do. So with 865, that is not a principal angle. So the principal angle will be less than 360, right? So if you go one full turn, that is 360. If you go 2 full turns, that would be 720. If you go 3 full turns, that would be 1080, and that would be too much. All right. So therefore, 865 degrees. If you subtract 720 degrees, that would give you 145 degrees, and there is your principal angle. Okay. Now, how do you find the expression for the measures of all the angles that are coterminal with this? Well, just like what happened in the previous check your understanding that I did, 145 degrees is your principal angle. To find the next coterminal, you add 360, and then you add 360 again, then you add 360 again. Or it's just adding 360n, all right? Now, once again, for those of you who are wondering, what about the negative angles, which are also coterminal? Well, instead of adding 360, you subtract 360, okay? And this expression takes care of it because n can be an integer. It could be -1. If n is -1, that means it becomes 145 degrees plus 306 minus 360, and that will give you a negative number, -215, whatever, okay? All right, so I'll stop here for now. I'll take a break. Maybe you would like to take a break also. Okay. I'm gonna be back in a little bit to continue with CYU number 3.